Okay, boys and girls, this is the take-home test. Here we are. We need to sort out everything that we know up to this point. Organic chemistry is cumulative. So that means that you always have to not only learn new reactions, but be able to continuously apply older reactions and add them to your repertoire of possible organic synthesis options. What you see in front of you here is a synthesis scheme. And so we want to be able to fill in the blanks as best as possible, and we want to use the hints that are available to us. So let's take a look. Let's go one step at a time, and let's see if we can sort these things out. So there are hints everywhere, and we need to take advantage of those to figure that out, okay? So let's think. What is DBN? Well, we have to go back to our previous knowledge and remember that DBN is a base. And so a base can do elimination. Well, I've got a leaving group. It's bromine, and bromine can leave. Why are there two products? Now let's check the hints in the products. I've got some hints here, and the hints are that, well, they have the same chemical formula. They have the same molecular formula. So what could have the same molecular formula, but require two different boxes? Well, it seems like that must be different only from the standpoint of some sort of isomerism, either structural isomerism or stereoisomerism. Well, if I'm going to use a base and I'm going to do elimination, then that's a difference of where the double bond is located. Remember that in an elimination reaction, there's generally a major and minor product, whether we're talking about the Zaitsev or the Hofmann product. And so in this case, I have a bromine and it can eliminate, and I can have a Zaitsev or a Hofmann product. So that means that I can have a double bond. Well, I'm going to go ahead and leave this here. That means I can have the double bond form here, or I could have the double bond form there. And so we want to be sure to figure out which one of these possibilities is the correct possibility to show in this box. And that's where the other hints come in at. Now, I'm going to have the reaction scheme is going to have to work. So every step in the scheme has to make sense. We can figure out what goes in the box by thinking about this reaction. So let's think back from this reaction and start from there, and that'll help us decide where to put the double bond in this box. We know certainly that this methyl group looks like this, and the only other thing we don't know is, do I put a double bond here and a methyl group there, or do I put a double bond here and the methyl group with no stereochemistry? Well, let's take a look at the product of the reaction that I've got circled in yellow. Well, it forms a carbonyl group, and the carbonyl group is formed by breaking a double bond, and the double bond is here and here. And remember, in the reverse sense, the oxygens go away and the double bond just reconnects. And so let me remove some of the clutter and let's take a look at what's going on with that. It looks like the product of this reaction is very symmetrical. And so notice that the stereochemistry of the two methyl groups is maintained. And so that means that whatever I start with, this methyl group has to have its stereochemistry. And so that means the double bond must have been here. And so what do? This is O3 and DMS as the second step. And that gets me there. And that tells me which one of the products of the elimination goes in that box. Turns out it's the minor product. Now, the major product goes in the other box, and that's the more substituted alkene. Okay, so what's next? Well, I could go backwards this direction, but it seems like I would still need to be able to figure out that. And I certainly can. It doesn't, I can go any direction I want. I think I'm just going to go ahead and go this direction. So I'm going to start off with this molecule. And I want to sort out how to make this molecule from it. And so I do that by examining what are the functional groups that are present. Well, it looks like I've got an OH group, and it looks like it added into the least substituted position. And it also looks like the hydrogen that got added along with it was added in a syn fashion, so on the same direction as the OH group. So what does that? What adds alcohols in an anti-Markovnikov formation? Only one reaction, BH3, THF, step 2, sodium hydroxide, and H2O2, hydroboration oxidation. It's also a syn addition. So we filled out that box. And what, doesn't that make sense too? Look what else happens. Both possible stereocenters are formed. Remember that OH can form in either direction, but at the end of the day, it's still syn addition. Okay, so now that I've done that, I can think about, well, what's going on with HBr? Wow, what does that do? Well, what am I going to use as a hint? Well, I got a hint here. The only thing I'm doing is changing the number of, is adding a bromine to it. So how do I do that? Well, I have to, again, I have to kind of think back to some previous reactions. And what would happen if I added HBr to an alcohol? Well, it seems like the alcohol would do a proton transfer. And then I would be able to make the alcohol into a good leaving group. And that good leaving group, the bromide that was left would then attack the carbon that the good leaving group is attached to, and it would do a substitution reaction. Okay, so I'm going to replace the OH with an alcohol or with a Br. So let's see how that works out. There's nothing that's changing over here, so I still have that. Let's see, I've got nothing that's changing over here, so I still have that one. And now I have a Br attached here. The question is what's the stereochemistry? Well, I have to remember that if I'm going to do this, and I know that this is what's happening because I have the hint of the BR, the formula to get me into what the structure could possibly be. I assume that that then must have happened SN2. And so I want to make sure that I show the correct stereochemistry. So I want to show that the bromine is now facing the other direction. Okay, and now one last thing. How did I get from here to here? That's the last box that we need to figure out. So I already know the product, and so hopefully now you see the relationship of what, how come you had to get everything correct, because I do want to specifically eliminate the bromine to form a double bond. Well, what double bond do I form? Do I form the Zaitsev product, or did I form the Zaitsev product or the Hoffman product? Well, it looks like this one is the Hoffman product. So in order to form the Hoffman product, I need a big bulky base. And so the answer to this one here is T-butoxide. Okay, I've answered the entire question. And so this is a good synthesis scheme to help you get your mind around all the different possible reactions. This is one type of synthesis problem, in addition to here's the product, just create it from all the reactions you know. So this is really good practice for being able to do that. Okay.